Hey, what's up everyone, Hicham from HAMZAOUI here for a new episode of how to create your own video game using Unity 3D. In this episode we're going to try to make our game more fun to play by adding some moving platforms, adding a spinning sound that is going to be deadly for our robot to make it respawn, and of course to do that we have to create some deadly surfaces and a position for our game to respawn. So execute your Unity 3D and let's do that! Well, basically what we want to do in our game is to make it more dynamic and more fun to play. We're going to add some movement to our platform and make them move from right to left, horizontally or vertically from up to down. So let's make this happen. Go inside the script folder and then we're going to create a new C# script. You can name it whatever you want. I'm just going to name it platform movement. Inside this script we're going to handle all the movement of our platform. Once naming finished, double click on the script and then we're going to create some attributes. Inside this script create a new public float and call it speed. This will be the speed of our movement, and give it a default number. Then we're going to create a new public float, it will be a int, and call it max limit. Give it a default value. For example, here I'm just going to give it 5 as a default value, and basically this attribute will be used as an indicator for our platform to say stop and go to the other direction. Otherwise it will go straight forward. Then create another public attribute. This one will be a boolean. It will indicate to our platform whether it's going to move vertically or horizontally, so it will be named is vertical movement. Create another attribute, a float one, that will take the initial position of our platform, so called platform initial position. Inside the start, at the beginning, we're going to see if we are in a vertical movement or horizontal one. So if is vertical, we should initialize the platform initial position. So this one we're going to initialize it by the y position, so equals transform.position.y of our platform. Else it will be the other position, so it will be the X position. Copy this code and change the Y by X. Now we're going to create a function that is going to handle the movement of our platform. Create a void. This is the move platform, and inside this function we're going to first create a temporary position as we do for movement, so vector 3 platform position. Let's add the temp first here, temp equals our actual position, this dot transform dot position. Then create an if statement. If is vertical movement, well, let's just write the else statement. Inside our first statement we're going to handle the vertical movement, so let's call temp platform position.y and make it plus equals to the speed, and do the same for the else statement, the horizontal one, so we're going to change the X movement. At this moment we're only just going to make our platform moving just in one direction. Now we're just going to handle the changes on the direction of our platform. Let's create a new function called void limit reached that will take a float, which is the platform position, and we're going to use it to say if we're going to change the position or not. Create a if statement. Inside it, write platform position higher or equals to our platform initial position, which was the initial position of our platform, plus max limit. That way we're going to say if we reach the limit that we wanted or not. And do the same for the other position, so the other direction, which is, let's copy the same code here and do the same thing in another direction. Here I'm just going to add this one, and inside that, lower than or equals platform initial position minus max limit. And that's it. Inside the code, we're just going to make our speed negative. So speed multiplied by a -1. That way, we're only going to change the direction easily by calling our new method here. So limit reached, and give it our temp platform position .y, and do the same for the else statement. We're just going to give it the temp platform position .x. Now we're just going to retake our newly edited temp platform position and apply it on our transform position. Here, don't forget to call our move platform inside the update, and we're going to add another attribute here to say if we are using a moving platform or just a fixed one. So is platform moving, a boolean one. Inside it, create an if statement. If is platform moving, then we're going to call our function that is going to make our platform moving, else nothing will happen to our platform. So let's check our code. Select a platform in the scene, go inside our script, drag and drop our code here, and of course we should update our prefab platform. You just have to drag and drop the changed platform. That way you see that our code is applied on all the platform used in the scene. Of course, nothing happens here because we didn't change our attribute here. So let's make this platform, for example, a vertical movement, and it is a moving platform. And let's see what happened. Here you can see that there is a vertically moving platform, a good animation, and we can only use is platform moving to have a horizontal one. So you can see here that our platform is moving and well animated. You can also change the speed if you want here for a more complex movement or more easy one like this one, and you can do whatever you want inside your game. You can add a higher value for a higher speed or whatever. Now let's see one interesting thing here. Let's make our robot move until the platform and make it land on it. See? Ugly, right? That's normal because our gravity speed isn't the same as the y speed of the platform. Let's correct this by doing some coding. Go inside the script folder here. Go inside the script called robot jump. We will handle this inside this robot jump script. The reason why we're using this script is because it is used inside the ground detector, and since we're gonna be using this for detecting the platform and correcting our movement, is a good thing. The solution that I chose is to make the robot parented to the platform. As a result, every changes that happens to the platform will be applied on the robot, including the movement. Alright, let's go back now to our script and do some coding. Inside our script robot jump, create a void function called onCollisionStay2D. This function will detect if we're on the platform or not. It takes as a parameter a collision 2D, and we're going to create a if statement that is going to check if we are on the platform or not. So if call dot game object dot tag. We're going to be using the tags for detecting if we're on a platform or not. Call it platform. I'm going to create this later. So if we are on a platform, that means that we should parent our robot to the platform, and since the code is inside the collision detector, we're going to call twice the parent. So transform.parent.parent equals call transform. That way it will be parented and is going to mimic all the changes that happens to the platform. So else we should remove the parenting. So to do that, we're only going to copy this code and make it equals to null. And make it equals to null. Alright, the next step now is to create our tag and to apply it to the prefab platform. So copy this name here, go back to the scene, go to the inspector, and select our platform. But we're going to select the prefab platform on the prefab, so resources platform, and then click on the untagged and add a tag. Now click on this plus button here, name it platform as we did in the script, save it, and reselect the prefab platform to choose our tag here. And thanks to this tag, we're going to detect if we're on the platform or not. Now we're going to test our script. Hit play, and you can notice that our robot here is parented to the platform he's on. So if he jumps to the other platform, he will be parented to this one and this one. And you can see that we have a clean animation and it follows the movement of the platform. Same thing for this one. Now let's make our game more fun to play by adding a spinning saw. Go to the object folder inside the sprite one and drag and drop our saw image here. What we want to do is to make our saw here spinning forward or backward, you choose. To make that happen, go inside scripts, create a new one, and call it spinning saw. Then inside this spinning saw, we're going to create some codes that will make this happen. Create a new attribute, public int, call it spinning speed, gives it a value, for example 2. Inside the update, call transform dot rotate, and inside that call a vector tree and dot forward or back. It depends to you, either you want to make it go forward or backward, and multiply it by the spinning speed. Select our saw here and drag and drop the code and hit play. It is very easy to make. That way you can see that our saw is spinning. You can change the spinning speed, it depends to you and what you want to do as a complexity for the game. Now we're going to create a movement from right to left, but for us it will be easy because we're just going to be using what we already done for the platform. And you can select the spinning saw, go to the platform movement, drag and drop it, and select is platform moving. And here we go. You can see that the program is well applied on our saw. And of course, to save all these changes, we need to create a new prefab here. Go to the resources, create new prefab, and you just have to name it spinning saw. And of course, select our saw and drag and drop it inside the prefab. Here, you're gonna see that everything that we already made are applied to our prefab. Alright, so let's make our saw more visually acceptable. Take your saw here, put it in the middle of this platform, and we're just going to change the scales and of course make it behind the platform by changing the Z position here. More. Alright, and let's see our final result. Hit play. Alright, now you can notice that our saw doesn't kill our robot. We need to create a respawner. So create a new game object, empty one, call it respawner. Like this, give it a selection, blue one for example. Let's change the position of it here. We want our robot to respawn once he's dead in that position. Select the asset image and let's make it more bigger. It will be like a acid surface that is going to kill our robot once it is on it. So click on add component, box glider 2D. I'm just going to rescale this one like this. Okay, here we go. We're gonna add some codes. Go to the scripts, create a new C# script, and we're going to call it respawner. Now go inside our respawner script here, and this script will be responsible of killing the robot and make it respawn. So create a public game object here, yeah, call it respawner. The respawner, actually we're going to modify it to make it transform, because it's taking all the transform of the respawner object. So copy this on collision into 2D that we just created on robot jump. If you want, I just want to copy it like this. Inside our function here, we're going to create an if statement that is going to test if it is the robot that hit the platform or not. So I'm going to be using the tag that we already created before for our robot here, robot tag. It's already set. So if call.gameObject.tag equals robot, then we should kill our robot and change the position of it. So easily we're going to make the position of our robot equals to the respawner. So calls.transform.position equals respawner. Here we go. Now go inside our asset, drag and drop the code on it. Of course we should take our respawner and drag and drop it inside this attribute, and let's see what happens. Bam! It makes the illusion that our robot is dead. Side, we only change the position of our robot. Alright, now we're going to save these changes on the platform. Let's go inside the resources folder and let's create a new prefab. Call it whatever you want, but I'm just going to call it deadly surface. Here we go, and of course drag and drop the asset image on the prefab, so that way we can duplicate it on the scene for the use on our game like this. Here we go. Alright, of course we're going to do the same thing for our spinning saw here to make it deadly for our robot. So hit F, add a new component on it. It will be a physics 2D, so add component, physics 2D, circle collider 2D to fit the shape of the saw. Go to the script folder, take our respawner code, and of course drag and drop our respawner here inside the attribute. Let's test now, and here we go. You can see that our respawner now is dangerous and deadly for our robot. That's what we want. And of course don't forget to save all the changes on the newly updated saw. Go to the resources and drag and drop our saw on the scene here inside the prefab. Alright, now you can see that on our game the background is blue and it is not fun and cool to see. So I'm just going to change the deadly surface position here. Alright, drag and drop our background image on the sprite folder. Change the Z position of it, like this one. You can either change it this way or select this 2D button, Alt, and of course changing your position wherever you want to make your background. Here we go. You can see that our game is more proper to see and gives the player a good sensation of a deep environment in playground. Alright, that's all for our episode here. I hope that you enjoyed it. Don't forget to subscribe to be notified of any new video. Hit a like, share or comment if you have any questions. See you in the next episode.